March 23, 1944. Yokosuka Naval Air Technical Arsenal, Japan. Lieutenant Commander Minoru Genda climbs into the cockpit of a captured American fighter, the Grumman F6F Hellcat. For 9 months, Japanese pilots have watched these machines systematically dismantle the Imperial Navy's air superiority across the Pacific. Intelligence reports called it crude. Propaganda dismissed it as another product of American mass production over precision engineering, the brute that defeated the elegant Zero through sheer numbers and industrial might. Genda's own squadron had lost 17 pilots to Hellcats during the Battle of the Philippine Sea. Now, finally, a Japanese test pilot would discover what made American engineering so effective. The external inspection seems to confirm everything. 5,400 pounds empty weight, nearly double the Zero's mass. The massive Pratt and Whitney R 2800 engine dominating the forward fuselage. American excess, everywhere. Thick armor plating, redundant systems, brutal construction. This looks like a flying tank rather than a fighter aircraft. But as Genda settles into the pilot's seat, something feels profoundly wrong. The canopy slides forward with smooth hydraulic precision, sealing with a solid mechanical click that Japanese aircraft never achieved. The instrument panel displays clear, logically arranged gauges behind armored glass. The control stick moves with firm, positive resistance that suggests engineering confidence rather than weight-saving desperation. This isn't crude manufacturing. This is systematic superiority disguised as industrial brute force. Japanese engineers had been dismissing American genius as mere production capacity. Genda adjusted the unfamiliar American seat, its thick padding and adjustable positions nothing like the Spartan canvas construction he knew from Zero cockpits. The Hellcat sat heavy on Yokosuka's concrete ramp, its massive 14-foot three-bladed propeller gleaming in the late afternoon sun. Serial number 41,863 had been recovered from a forced landing near Truk Lagoon, one of only 3 intact Hellcats captured during 20 months of devastating combat losses. What Imperial Navy intelligence desperately needed to know was simple. Exactly how were American pilots achieving kill ratios that had reversed from 12-1 in Japan's favor to nearly 19-1 against Japanese aircraft? The morning briefing had reinforced everything Genda thought he understood. Captain Masatake Okumiya stood before a wall-mounted diagram of the F6F Hellcat, pointer-tapping key features with obvious disdain. "Gentlemen, this aircraft represents American philosophy of warfare through material superiority rather than spiritual strength. 2,300 pounds heavier than our Zero. 70% more engine displacement consuming fuel at rates that would cripple our logistics. The Americans win, not through superior design, but through overwhelming industrial production that allows them to waste resources we must carefully husband." Okumiya's voice carried the institutional certainty of officers who had never questioned Japanese technological supremacy. Our Zero remains aerodynamically superior. More maneuverable, longer range, better climb performance. American pilots achieve victory only through numerical advantage and suicidal tactics that sacrifice aircraft freely. Your job is to document the specific, wasteful design choices that reveal American engineering inferiority. Genda had nodded along with the other test pilots, accepting the conventional wisdom that had guided Japanese aviation development since the war's beginning. After all, the Zero's early combat record seemed to prove Japanese design philosophy correct. The A-6M had dominated Pacific skies for nearly 2 years, achieving kill ratios that made American fighters appear hopelessly outclassed. But now, strapped into the actual American aircraft, Genda encountered his first troubling detail. The pilot's seat didn't just have armor plating behind it. The entire cockpit was surrounded by protective steel. 3/4-inch armor backed the seat. Bulletproof glass protected the instrument panel. Steel plating covered critical systems throughout the fuselage. His Zero offered protection equivalent to a civilian aircraft. This American fighter provided a fortified battle station. Genda ran his fingers along the seat armor, finding heavy steel plate expertly integrated into the aircraft structure. He shifted his attention to the instrument panel, where American engineering philosophy revealed itself in devastating detail. From his position in the cockpit, Genda could see instruments designed for combat reliability rather than weight optimization. The airspeed indicator, altimeter, artificial horizon, and compass occupied prominent positions with clear visibility and logical arrangement. But what struck him most was the quality of construction. Instruments mounted in shock-absorbing brackets, wiring protected by armored conduits, backup systems for critical flight controls. The Americans had designed this aircraft assuming battle damage was inevitable rather than theoretical. The control stick felt substantial in Genda's grip, its movement precise and well-damped compared to Japanese standards. He tested the rudder pedals, finding responsive feedback through heavy-duty control cables that would survive damage destroying lighter Japanese systems. The throttle quadrant mounted to his left contained levers for propeller pitch, mixture control, and power settings, each moving with positive mechanical authority that suggested months of service life rather than hours. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Everything seemed designed for sustained combat operations, rather than minimal weight achievement. Genda began his systematic pre-flight checklist, the same methodical approach he applied to every aircraft evaluation. Fuel capacity, 250 gallons internal, plus provisions for external drop tanks. His mental calculations put combat radius at approximately 950 miles, with external tanks, nearly matching the Zero's vaunted range while carrying significantly heavier armament and protective systems. Maximum takeoff weight, 15,413 pounds, more than double a loaded Zero, yet powered by an engine producing over twice the horsepower. The weight penalty for armor and systems appeared offset by raw power that Japanese aviation could not match. The armament panel told another story of American priorities that Genda found difficult to comprehend. 6 Browning M2 50-caliber machine guns mounted in the wings, 3 per side, each gun loaded with 400 rounds of ammunition. Total ammunition capacity, 2,400 rounds. Fire rate per gun, 800 rounds per minute. Combined sustained fire rate, 4,800 rounds per minute. Genda performed the calculations 3 times, unable to believe American fighters carried ammunition loads equivalent to entire Japanese fighter squadrons. His Zero mounted 2 20mm cannon with 60 rounds each and 2 7.7mm machine guns with 680 rounds total. Maximum sustained fire time, approximately 34 seconds before ammunition exhaustion left the aircraft defenseless. The Hellcat could maintain continuous fire for nearly 30 seconds at maximum rate, or carefully aimed bursts for several minutes of combat engagement. The Americans had built a fighter that could afford to miss, then shoot again, then shoot again. Japanese pilots had to make every round count or face combat with empty guns. Genda fired up the massive R-2800 engine, following American procedures translated by Yokosuka technical officers. The big Pratt and Whitney caught immediately, settling into a smooth idle that produced more horsepower at rest than a Zero's engine at full combat power. The sound alone was intimidating, a deep, authoritative rumble that spoke of massive displacement and unlimited industrial capacity. Total power output, 2,000 horsepower at military power, 2,300 horsepower with war emergency boost. His Zero generated 940 horsepower. The American fighter had more than double the power, driving a heavier airframe to speeds Japanese aircraft could not match. During taxi tests, more concerning details emerged. The landing gear felt absolutely solid, heavy oleo struts designed for carrier operations, absorbing every imperfection in the taxiway surface with confidence Japanese systems never achieved. The tail wheel, fully retractable unlike Japanese designs, suggested attention to aerodynamic efficiency, despite the aircraft's brutal appearance. American engineers had apparently optimized every detail, while maintaining the massive structural strength that characterized all their combat equipment. As Genda aligned the Hellcat on Yokosuka's main runway for his first test flight, one final detail crystallized his growing unease. The aircraft's empty weight exceeded a fully loaded Zero by over 1,000 pounds, yet it was designed to operate from carrier decks in combat conditions. American carriers must be producing aircraft at rates that made individual losses irrelevant, or American engineering had achieved strength-to-weight ratios that Japanese metallurgy could not duplicate. He advanced the throttle for takeoff, feeling the Hellcat surge forward with authority that made Japanese fighters seem anemic. Rotation speed came at 105 miles per hour, faster than a Zero, but the acceleration to flying speed felt effortless despite the aircraft's massive weight. As the landing gear retracted with smooth hydraulic precision, and Genda climbed toward his planned test altitude of 15,000 feet, he realized he was not evaluating crude engineering. He was flying evidence that might shatter the most fundamental myth of Japanese aviation superiority. The instruments showed exactly what Genda had begun to suspect during his pre-flight inspection. This was not wasteful American excess. This was systematic engineering advantage that made Japanese design philosophy appear desperately inadequate by comparison. Captain Masatake Okumiya had spent 18 months analyzing American aircraft development for the Imperial Navy's Technical Intelligence Division. His conclusions, presented in classified briefings throughout 1943, had shaped Japanese aviation strategy and influenced procurement decisions worth millions of yen. The assessment remained consistent. American fighters succeeded through numerical superiority rather than technical excellence. Okumiya's position carried enormous institutional weight. He had served as a Zero squadron commander during the China campaigns, experiencing firsthand the aircraft's devastating effectiveness against inferior Chinese fighters. His combat experience, combined with technical training at Tokyo Imperial University, created an authoritative voice that few junior officers dared question. The official Imperial Navy assessment concluded that American aviation programs relied on crude mass production techniques that sacrificed performance for manufacturing simplicity. Japanese engineering retained decisive qualitative advantages despite growing American numerical superiority. Okumiya understood the strategic implications. If American aircraft truly matched Japanese technical capabilities, the entire Pacific War strategy required fundamental revision. Japan's plan for quick, decisive victories had been predicated on achieving air superiority through superior equipment and training. Superior, enemy technology would make that strategic approach impossible. Genda's initial flight report landed on Okumiya's desk 6 days after the Hellcat evaluation. The document contained 31 pages of detailed technical observations, performance measurements, and comparative analysis that challenged every assumption underlying Japanese aviation doctrine. Okumiya had expected confirmation of American inferiority. Instead, Genda's data painted a devastating picture of systematic Japanese disadvantage, disguised by propaganda and wishful thinking. Maximum speed at sea level, 380 miles per hour. Okumiya pulled comparative specifications for Japanese fighters. The Zero A6M5, considered the pinnacle of Japanese fighter development, achieved 351 miles per hour under ideal conditions. The supposedly crude American fighter flew nearly 30 miles per hour faster while carrying twice the ammunition, 4 times the armor protection, and self-sealing fuel, tanks that made it virtually immune to the catastrophic fires that destroyed Zeros routinely. Service ceiling measurements proved equally disturbing. The Hellcat reached maximum operational altitude at 37,300 feet. Japanese fighters struggled to maintain combat effectiveness above 30,000 feet, where thin air degraded the Zero's lightweight construction advantages. The American fighter could operate at altitudes where Japanese interceptors could not reach, making strategic bombing defense nearly impossible. Genda's range calculations provided another shock. With standard internal fuel, the Hellcat achieved combat radius of approximately 660 miles. With external drop tanks, operational radius extended to 950 miles. essentially matching the Zero's celebrated range while carrying armament and protective systems that Japanese engineers insisted made long-range operations impossible. The Americans had achieved everything Japanese design philosophy claimed could not coexist in a single airframe. Okumiya convened his technical staff to verify Genda's findings through independent analysis. Chief Engineer Commander Jiro Horikoshi, designer of the legendary Zero fighter, had supervised Japanese aircraft development since the mid-1930s. His team examined detailed photographs and measurements from the captured Hellcat, comparing construction techniques, material specifications, and manufacturing approaches to Japanese standards. Their conclusion contradicted decades of Japanese engineering assumptions. American construction methods appeared optimized for combat survivability rather than weight minimization. The Hellcat's wing structure used heavy spars and thick skin that could absorb significant battle damage and continue flying. Japanese fighters achieved lighter weight through minimal structure that failed catastrophically when damaged. Manufacturing tolerances maintained consistency across all examined components, suggesting quality control standards that Japanese factories could not match despite careful craftsmanship. Material analysis revealed systematic use of superior alloys throughout critical components. The Americans were not compensating for poor engineering through heavy construction. They were using better materials, better processes, and better design integration to achieve performance that Japanese aviation could not duplicate. Defensive armament analysis exposed perhaps the most critical American advantage. The 650 caliber machine guns delivered a combined weight of fire that exceeded Japanese expectations by orders of magnitude. Horikoshi's team calculated that the Hellcat could maintain continuous fire for 27.5 seconds at maximum rate, delivering over 2,000 rounds into a target area. The sheer volume of fire made precision aiming almost unnecessary. American pilots could spray entire engagement zones with enough ammunition to guarantee hits regardless of individual marksmanship skill. Japanese fighters carried ammunition sufficient for approximately 30 seconds of total firing time, forcing pilots to achieve perfect accuracy or face combat with empty weapons. The Americans had apparently decided that ammunition weight was irrelevant compared to combat effectiveness. They simply loaded enough rounds to guarantee mission success, regardless of how much each bullet weighed. Okumiya requested additional Hellcat specimens for comparative testing, but American air superiority had made capturing intact aircraft nearly impossible. The single example at Yokosuka represented extraordinary luck. Future captures would require battlefield victories that seemed increasingly unlikely as American production accelerated. Genda and 2 additional test pilots conducted systematic evaluation flights documenting performance across multiple flight regimes. Results remained consistent across all testing parameters. The Hellcat represented systematic engineering superiority rather than isolated design success. American fighter development had apparently maintained steady advancement, while Japanese programs stagnated after the Zero's early victories. Intelligence reports from combat theaters began supporting Okumiya's worst fears. Japanese fighter loss rates had climbed steadily since mid-1943. During early war operations, Zero squadrons achieved kill ratios exceeding 12-1 against American fighters. By 1944, those ratios had reversed catastrophically. Hellcat squadrons were achieving 19-1 kill ratios against Japanese aircraft in major engagements. The Battle of the Philippine Sea in June 1944 had been particularly devastating. American carrier fighters destroyed over 600 Japanese aircraft while losing fewer than 30 Hellcats. Japanese pilots called it the Great Marianas Turkey Shoot, a title that captured the one-sided slaughter with bitter accuracy. The aircraft that was supposed to represent crude American engineering was systematically destroying Japan's most experienced combat pilots. American fighter production had reached levels that seemed impossible to Japanese industrial planners. Grumman's factories were producing over 500 Hellcats per month by mid-1944. Total American fighter production exceeded 3,000 aircraft monthly across all manufacturers. Japan's entire aviation industry struggled to produce 600 fighters per month while replacing combat losses and expanding training programs simultaneously. The numbers revealed strategic realities that Japanese leadership refused to acknowledge publicly. American industrial capacity exceeded Japanese manufacturing by factors that made prolonged warfare mathematically unwinnable. Every Japanese pilot killed represented irreplaceable training and experience. Every American pilot lost could be replaced by 3 fresh graduates from massive training programs that graduated thousands of pilots monthly. Okumiya compiled comprehensive findings for Imperial Navy review, but institutional resistance emerged immediately. Senior officers had committed military strategy based on assumptions of Japanese technical superiority through spiritual strength and design elegance. Procurement programs worth enormous resources were predicated on qualitative advantages, offsetting American numerical superiority. Intelligence agencies had built threat assessments around Japanese aviation excellence that combat results no longer supported. The evidence was becoming mathematically undeniable. American aircraft development had not just matched Japanese capabilities, it had surpassed them systematically across every performance parameter that mattered in modern aerial combat. The Hellcat, symbol of American industrial brutality and supposed engineering crudeness, was an optimized weapon system that made Japanese fighters appear desperately inadequate by direct comparison. Okumiya's team had uncovered not just aircraft specifications, but exposure of strategic self-deception that threatened Japan's entire war strategy. Genda pushed the Hellcat into its first high-speed dive test on March 29, 1944. Climbing to 25,000 feet before rolling into a 40-degree descent angle, the aircraft accelerated smoothly through 300 miles per hour, then 350, approaching speeds that would destroy most Japanese fighters through structural failure or control surface flutter. At 410 miles per hour, Genda felt none of the vibration or structural stress that characterized Japanese aircraft at high speed. The controls remained responsive and precise. No flutter developed in the wings or tail surfaces. The Hellcat flew with absolute stability at speeds that would tear a Zero apart. He continued the dive to 450 miles per hour, well beyond any speed he had experienced in Japanese aircraft. The Hellcat remained completely controllable, its massive structure absorbing aerodynamic loads that would cause catastrophic failure in lighter airframes. American test pilots apparently dove these fighters routinely at speeds Japanese engineers considered impossible. Recovery from the high-speed dive revealed another fundamental advantage. The Hellcat's controls remained effective throughout the speed range, allowing immediate maneuvering after high-speed attack runs. Japanese fighters required careful speed reduction before attempting combat maneuvers, giving American pilots crucial seconds to escape or re-engage on advantageous terms. The structural analysis became even more disturbing when Genda began simulated combat maneuvers. Banking the aircraft into maximum rate turns produced no stress warnings, no structural complaints, no indications of approaching design limits. The Hellcat accepted aggressive maneuvering, with mechanical confidence that suggested enormous strength margins Japanese aircraft never possessed. The thick wing skin and heavy internal structure clearly allowed combat maneuvering that would overstress Japanese airframes. Commander Horikoshi's engineering team had meanwhile completed detailed armor assessment using the captured aircraft as a reference specimen. They measured, weighed, and documented every protective element integrated into the Hellcat's design. The results confirmed Genda's operational observations in devastating detail. Total armor weight, 212 pounds of hardened steel plate protecting critical systems and crew positions. The pilot's seat backed by 3/4-inch armor capable of stopping 20mm cannon rounds from directly astern, armored glass protected forward visibility while maintaining optical clarity. Steel plating covered the engine compartment, protecting vital components from ground fire during strafing runs. Most impressively, the fuel system incorporated self-sealing tanks that automatically sealed bullet holes through vulcanized rubber layers. Horikoshi's team tested the self-sealing capability by puncturing a removed fuel tank with 7.7mm rounds. The holes sealed completely within seconds, preventing fuel loss that would leave Japanese fighters burning or force landing from minor battle damage. American pilots flew aircraft that could absorb significant damage and return to base. Japanese pilots died from single lucky hits that any protective systems could have prevented. Intelligence reports from active combat zones provided disturbing confirmation of testing results. American fighter pilots were reporting successful returns to base after sustaining damage that would destroy Japanese aircraft outright. Hellcats landed aboard carriers with dozens of bullet holes, damaged control surfaces, and partial engine failures that pilots survived through robust construction and redundant systems. The psychological impact on Japanese pilots proved as devastating as the technical disadvantage. Knowing their aircraft offered no protection while American fighters could absorb concentrated fire, created combat conditions that favored enemy morale as much as enemy equipment. Genda discovered the Hellcats' most significant tactical advantage during mock combat exercises against Japanese fighters. Yokosuka's chief test pilot, Lieutenant Saburo Sakai, flew a A6M5 in simulated engagements designed to identify American tactical doctrine. The results shattered Japanese assumptions about aerial combat in ways that technical specifications alone could not convey. In traditional turning dogfights, the Zero maintained its legendary maneuverability advantage. Sakai could complete tighter circles, achieve better instantaneous turn rates, and maintain energy in sustained maneuvering that Japanese doctrine considered decisive for fighter combat. But Genda quickly discovered that American pilots simply refused to engage in turning battles where Japanese advantages were maximized. Using pure speed and diving attacks, the Hellcat transformed every engagement into a shooting exercise where Japanese maneuverability became irrelevant. Genda executed slashing high-speed passes from altitude, diving through Sakai's defensive maneuvering with accumulated speed that made zero response impossible. The American fighter could accelerate away from pursuit, climb to altitude using superior power, then repeat the attack sequence indefinitely. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Japanese pilots had no counter to tactics that exploited American strength while avoiding Japanese advantages. Sakai attempted every defensive maneuver in his extensive combat repertoire. Tight turns, split S reversals, high-speed scissors, defensive spirals that had saved his life in dozens of real combat engagements. Nothing worked against an opponent who simply refused to turn, instead using speed and altitude to attack from positions where Japanese fighters could not respond effectively. The mock combat revealed why American kill ratios had reversed so dramatically. Japanese pilots were fighting according to doctrine developed against inferior Chinese aircraft. American pilots were fighting according to intelligence-driven tactics that systematically exploited Japanese fighter weaknesses while maximizing American advantages. Combat radius calculations revealed another fundamental American advantage that Japanese planners found difficult to accept. The Hellcat carried sufficient fuel for extended combat operations far from base or carrier, enabling American fighters to maintain combat air patrols that Japanese aircraft could not match without compromising combat effectiveness. Fuel consumption at cruise power settings measured 110 gallons per hour, actually more efficient than expected for such a powerful engine. With 250 gallons internal fuel plus provisions for external tanks, the Hellcat achieved operational flexibility that made strategic air superiority inevitable given American production capacity. Japanese fighters achieved longer absolute range through extreme fuel economy and minimal systems, but American fighters achieved superior combat persistence through raw fuel capacity and efficient power management. The distinction proved decisive in actual combat operations, where battle damage, navigation errors, and tactical requirements made theoretical maximum range meaningless compared to practical operational capability. The armament effectiveness analysis yielded perhaps the most psychologically devastating results for Japanese technical staff. The 650 caliber machine guns provided not just overwhelming volume of fire, but armor-penetrating capability that made Japanese aircraft defensively helpless. Horikoshi worked with ballistics specialists to analyze exact penetration characteristics for American 50 caliber ammunition against representative Japanese aircraft structures. Their calculations showed that standard ball ammunition could penetrate zero aluminum skin and structure at ranges exceeding 1,000 yards. Armor-piercing rounds defeated even the minimal protective plating installed on later Japanese fighter variants. Most devastatingly, incendiary ammunition ignited fuel systems with catastrophic effectiveness against unprotected Japanese fuel tanks. A single incendiary round striking any Japanese fuel system created immediate conflagration that consumed the entire aircraft within seconds. American pilots had apparently learned to use ammunition mixing that included tracer, armor-piercing, and incendiary rounds in patterns that guaranteed fuel fires, regardless of where bullets struck the target aircraft. The Americans had systematically analyzed Japanese fighter vulnerabilities, then optimized their ammunition to exploit those weaknesses with industrial precision. By contrast, Japanese 20mm cannon rounds, while individually more powerful than 50 caliber bullets, suffered from limited ammunition capacity and trajectory problems that reduced practical effectiveness. The cannon shells could inflict devastating damage when they connected, but low ammunition capacity meant Japanese pilots faced constant ammunition management that American pilots with over 2,000 rounds total never worried about. The psychological burden of counting rounds, rationing ammunition, and holding fire until perfect shot opportunities materialized created combat stress that degraded Japanese pilot effectiveness, regardless of individual training quality. American pilots could fire exploratory bursts, adjust aim, fire again, and continue shooting until either hitting the target or forcing defensive maneuvering that created new attack opportunities. The industrial philosophy difference could not have been more stark. Genda's final evaluation flight on April 5th revealed the Hellcat's most profound advantage. It was an aircraft designed for sustained combat operations by average pilots rather than perfect performance by exceptional aviators. Every system, every design decision, every engineering choice reflected assumptions that combat would be prolonged, pilots would make mistakes, and aircraft must enable mission success despite imperfect execution. Japanese fighters demanded perfect piloting and offered no margin for error. American fighters provided systematic advantages that made average pilots effective and excellent pilots devastating. The numbers told an inescapable story. An aircraft dismissed as crude engineering was actually an optimized weapon system that made Japanese design philosophy appear fatally misguided. Commander Horikoshi's engineering team completed their comprehensive analysis on April 12, 1944, delivering a 73-page technical report that systematically documented American engineering advantages across every measured parameter. The document contained precise specifications, comparative performance data, and detailed technical drawings that should have forced immediate revision of Japanese aviation strategy. Instead, the report disappeared into classified files within days of its completion. The comparative data painted a devastating picture of Japanese technological disadvantage that senior leadership refused to acknowledge publicly. The Hellcat carried 2,400 rounds of 50 caliber ammunition compared to the Zero's total firing time of 34 seconds, more than 4 times the sustained combat capability. At combat altitude of 20,000 feet, the American fighter flew 43 miles per hour faster than the best Japanese fighter, while carrying twice the ammunition and 4 times the armor protection. Fuel consumption per combat hour actually favored the Hellcat, despite its much larger engine, demonstrating superior propeller efficiency and engine management compared to Japanese systems. Manufacturing analysis revealed even more disturbing realities about relative industrial capabilities. Intelligence estimates suggested Hellcat assembly required approximately 16,000 man-hours compared to 18,000 for a Zero, despite the American fighters' greater complexity and protective systems. Superior manufacturing processes, better tooling, and systematic quality control apparently made American production more efficient while maintaining higher performance standards. Material quality showed consistent superiority throughout all examined components. American aluminum alloys demonstrated better strength-to-weight ratios than Japanese materials. Steel armor used advanced heat treatment that Japanese metallurgy could not duplicate. Even minor components like fasteners and wiring showed superior quality control compared to Japanese production standards. The vaunted Japanese precision craftsmanship existed more in propaganda than measurable technical specifications. American mass production was apparently achieving quality standards that Japanese artisanal manufacturing approaches could not match. Genda documented these advantages during extended flight testing throughout April and May. Engine reliability proved exceptional, with no mechanical failures during 47 test flights totaling 63.2 hours. Hydraulic systems operated flawlessly, despite Japanese assumptions that complex American mechanisms would prove maintenance-intensive. Electrical systems showed robust redundancy that kept critical instruments functioning even when battle damage disabled primary power sources. The strategic implications became mathematically clear when Horikoshi's team analyzed actual combat loss data from Pacific theaters. American fighter losses remained consistently below 10% per mission, even during major carrier battles, where combat intensity reached maximum levels. Japanese fighter losses exceeded 30% per mission during the same engagements, creating an attrition rate that would eliminate Japanese air power within months, regardless of pilot training or tactical modifications. The Hellcats' protective systems explained the loss rate differential. American pilots survived battle damage that killed Japanese pilots. They returned to base in damaged aircraft that Japanese pilots would have abandoned. They accumulated combat experience through multiple engagements, while Japanese veterans died from damage their aircraft could not absorb. Experience advantages compounded with each engagement as American pilots learned while Japanese pilots perished. Intelligence analysts had compiled comprehensive production statistics showing the true scale of American industrial dominance. Hellcat production had reached 512 aircraft per month by April 1944 from a single manufacturer. Total American fighter production exceeded 3,000 aircraft monthly across all types. Japan's entire aviation industry produced fewer than 700 fighters per month, while struggling to replace combat losses that eliminated entire air groups in single battles. The Americans were not compensating for inferior technology through numbers. They were producing superior technology at rates that made Japanese resistance mathematically impossible to sustain. The strategic bombing campaign against Japanese industrial targets was accelerating systematically, destroying manufacturing capacity faster than remaining factories could expand production. American air superiority made daytime industrial operations nearly impossible across major Japanese production centers. Genda's final report documented the complete reversal of technological advantage that Japanese leadership refused to acknowledge. American fighter development had apparently maintained steady advancement through systematic engineering and industrial investment, while Japanese programs stagnated after the Zero's early successes. The F-8F Bearcat entering American service in late 1944 represented further performance improvements that made even the Hellcat appear conservative by comparison. Strategic aviation doctrine itself required fundamental revision based on Genda's findings, but institutional momentum proved more powerful than technical evidence. Japanese military leadership continued planning operations based on assumptions of pilot quality, compensating for equipment disadvantages, despite mounting evidence that no amount of training could overcome systematic technical inferiority. The institutional resistance to Genda's revelations proved immediate and absolute. Imperial Navy procurement officials arrived at Yokosuka on April 18th, with orders to classify all evaluation results as top secret. Military strategy depended on maintaining pilot morale through belief in Japanese technical excellence. Public acknowledgement of American superiority would undermine combat effectiveness more certainly than actual equipment disadvantages. Senior commanders reviewed Genda's preliminary findings during closed briefings in Tokyo. The implications challenged fundamental assumptions that had guided Japanese military planning since the war's beginning. If American aircraft were superior rather than merely numerous, entire strategic concepts required revision. Defense budgets justified by qualitative advantages might face scrutiny if those advantages proved illusory. Horikoshi received orders to suspend further Hellcat evaluation and focus on next-generation Japanese fighter development. The official explanation cited resource constraints and shifting technical priorities. Genda was reassigned to operational fighter squadrons, effectively removing him from enemy technology assessment programs. But exposure to American capabilities had already changed his understanding of the war's likely outcome. Technical specifications existed in multiple copies distributed among test pilots, engineers, and intelligence analysts throughout Yokosuka. Performance measurements, combat analysis, and comparative data spread through informal channels, despite official classification orders. Operational squadrons began receiving unofficial tactical guidance, explaining American fighter capabilities and suggesting defensive tactics that might improve Japanese survival rates. Combat pilots learned that the Hellcats' advantages made traditional dogfighting suicidal. The only viable approach involved using speed to escape unfavorable engagements rather than attempting to fight American fighters on any terms. The 4,800 rounds per minute fire rate became common knowledge among Japanese squadrons, creating psychological impact as devastating as the actual technical disadvantage. Pilots knew they faced aircraft that could afford to miss repeatedly, while Japanese ammunition limits forced perfect accuracy or combat helplessness. Genda's work had exposed strategic reality that Japanese propaganda could not suppress indefinitely. Systematic underestimation of American capabilities, combined with overestimation of Japanese technical advantages, had created a strategic situation that made prolonged warfare unwinnable, regardless of pilot courage or tactical innovation. Genda's comprehensive evaluation report vanished into Imperial Navy classified archives on April 22, 1944, stamped with security classifications designed to prevent widespread distribution that might damage military morale. Official policy continued, maintaining that Japanese fighters remained qualitatively superior to American equipment despite growing numerical disadvantages. The institutional machinery of military doctrine proved more powerful than technical evidence, transforming inconvenient facts into state secrets that could not challenge established strategic narratives. The classification orders came with Genda's immediate reassignment to the 203rd Air Group operating from Rabaul, effectively ending his involvement with captured American equipment evaluation. Horikoshi received similar instructions, with technical staff redirected toward developing next-generation Japanese fighters that might restore competitive balance. The Hellcat specimen that had provided such devastating evidence of American engineering superiority was transferred to a storage facility where it would remain hidden from further analysis that might demoralize Japanese aviation personnel. But Genda's technical documentation had already begun circulating through unofficial channels among combat units, desperate for any tactical advantage against increasingly dominant American air power. Squadron intelligence officers quietly distributed summaries of Hellcat capabilities, optimal evasion techniques, and survival tactics derived from Yokosuka testing. The information traveled through personal networks rather than official distribution systems, reaching operational squadrons faster than classified reports could be suppressed through bureaucratic control. Frontline fighter groups began receiving detailed briefings on Hellcat capabilities during May 1944. Squadron commanders learned that the 650 caliber armament delivered concentrated fire that made close-range combat suicidal for unprotected Japanese aircraft. The 4,800 rounds per minute combined fire rate became standard briefing content, creating psychological impact as significant as the actual technical disparity. Combat results validated Genda's predictions with mathematical precision. Japanese fighter loss rates climbed dramatically as American carrier task forces launched increasingly aggressive operations throughout the Central Pacific. During the Battle of the Philippine Sea in June 1944, Hellcat squadrons achieved kill ratios exceeding 19-1 against Japanese aircraft. Over 600 Japanese fighters destroyed for fewer than 30 American losses in what became known as the Great Marianas Turkey Shoot. The engagement demonstrated exactly what Genda had documented through systematic testing. Japanese pilots attempting traditional dogfighting tactics against Hellcats, equipped with overwhelming firepower, superior speed, and protective systems, found themselves systematically slaughtered, regardless of individual skill or tactical innovation. The Americans had apparently trained their pilots to exploit every advantage Genda had identified, creating combat conditions where Japanese aircraft were simply outmatched across every performance parameter. Japanese aviation responded by shifting tactics toward kamikaze operations, where pilot survival became irrelevant and aircraft protection systems offered no advantage. By late 1944, conventional fighter operations had essentially ceased, as Japanese commanders recognized that trained pilots could inflict more damage through suicide attacks than through traditional air combat against technically superior American fighters. The strategic shift from fighter combat to kamikaze operations represented implicit acknowledgement of the technical realities that Genda had documented. Japanese fighters could not defeat American aircraft through conventional engagement. Remaining pilots and aircraft became expendable weapons aimed at American naval vessels rather than reusable combat assets intended for sustained operations. American fighter production continued accelerating throughout 1944, while Japanese manufacturing capacity declined under systematic strategic bombing. Grumman's factories produced over 12,000 Hellcats during 1944 alone, more fighters than Japan's entire aviation industry manufactured across all types. The production differential made attrition warfare mathematically impossible for Japanese forces, regardless of tactical modifications or strategic innovations. Hellcat squadrons operating from American carriers achieved total air superiority throughout the Western Pacific by early 1945. Japanese fighters surviving the catastrophic losses of 1944 were largely grounded by fuel shortages, spare parts limitations, and the systematic destruction of experienced pilots who could have trained replacement aircrews. The aircraft that Japanese intelligence had dismissed as crude engineering had systematically destroyed Japanese air power through superior performance, overwhelming firepower, and industrial production that Japanese planners had never anticipated. The contrast with Japanese fighter operations became stark during the final year of Pacific combat. American pilots accumulated dozens of combat missions, building experience and tactical proficiency through survival enabled by robust aircraft design. Japanese pilots typically survived fewer than 6 combat sorties before being killed or wounded, creating experience deficits that no amount of peacetime training could overcome. The Hellcats' protective systems made the survival differential inevitable. American pilots walked away from battle damage that killed Japanese aviators. They returned to base in aircraft riddled with bullet holes that would have destroyed Zeros outright. They accumulated combat knowledge through repeated engagements, while Japanese pilots died learning lessons that could not be transmitted to subsequent replacement pilots. Genda received unofficial confirmation of his findings' accuracy through combat reports from his own squadron operations. The 203rd Air Group suffered 73% casualties during 3 months of operations against American carrier task forces. Nearly every engagement followed the pattern Genda had predicted. Japanese fighters attempting to close with American formations were destroyed at long range by concentrated .50 caliber fire before achieving firing positions with their own limited ammunition weapons. The few Japanese pilots who survived close-range combat reported that Hellcats simply refused to engage in turning fights where zero maneuverability might provide advantages. American fighters used speed and diving attacks that exploited superior power and structural strength while avoiding any engagement geometry where Japanese aircraft characteristics were favorable. The tactical discipline suggested systematic training based on technical intelligence, exactly as thorough as Genda's own evaluation had been. Intelligence analysts compiled devastating statistics showing the true scale of air power reversal. During early war operations in 1942, Japanese fighters had achieved kill ratios exceeding 12-1 against American aircraft. By mid-1944, those ratios had reversed to approximately 19-1 in favor of American fighters. The statistical swing represented complete technological and tactical dominance that made continued Japanese fighter operations militarily counterproductive. The psychological impact on surviving Japanese pilots proved as devastating as the material losses. Knowing their aircraft offered no protection, while American fighters absorbed concentrated fire, created combat stress that degraded performance, regardless of individual courage or training quality. Japanese aviators increasingly refused combat when possible, choosing to jettison bombs and flee rather than engage Hellcat formations that represented near-certain death. Genda filed informal reports documenting the combat reality that official channels refused to acknowledge. His recommendations focused on defensive tactics that might improve Japanese survival rates rather than offensive operations that intelligence had proven tactically impossible against superior American equipment. The suggestions included avoiding combat entirely when outnumbered, using weather and terrain to escape unfavorable engagements, and abandoning traditional dogfighting doctrine in favor of pure survival tactics. Senior commanders ignored the recommendations, continuing to order conventional fighter operations based on assumptions of Japanese pilot quality, compensating for equipment disadvantages. The institutional refusal to adapt tactics to technical reality resulted in the systematic destruction of Japan's remaining experienced pilots during suicidal missions against American forces that possessed overwhelming material. Advantages. The post-war intelligence review would eventually confirm every technical assessment in Genda's classified report, but institutional acknowledgement remained impossible during the conflict itself. Japanese military leadership could not publicly admit American technical superiority without undermining the ideological foundations of the entire war effort. Propaganda emphasizing spiritual strength over material resources required maintaining the fiction of Japanese qualitative advantages despite mathematical evidence to the contrary. Genda survived the war and returned to civilian aviation, carrying knowledge of American capabilities that had proven accurate in every technical detail. His systematic approach to aircraft evaluation, prioritizing measurable performance over ideological assumptions, represented methodology that Japanese institutions had rejected to their strategic detriment. The courage to document uncomfortable truths, regardless of institutional preferences, had been classified as disloyalty rather than recognized as essential intelligence work. The captured Hellcat remained in storage at Yokosuka throughout the war's final year, a symbol of American industrial and technical dominance that Japanese authorities could neither destroy nor publicly acknowledge. After Japanese surrender in August 1945, American occupation forces recovered the aircraft along with Genda's complete technical documentation. The reports provided American intelligence analysts with valuable insights into Japanese understanding of their own technical disadvantages and institutional failures that had prevented effective response. Genda filed his final assessment of Japanese aviation failure in October 1945, 6 weeks after formal surrender ceremonies had ended Pacific combat operations. His conclusion remained as direct and technically rigorous as his original Hellcat evaluation. American fighter development had maintained systematic advancement through sustained engineering investment and industrial capacity that Japanese planners had catastrophically underestimated. Fear of acknowledging enemy technical superiority had prevented tactical adaptations that might have reduced Japanese losses, even if they could not prevent ultimate defeat. The numbers told their own story with mathematical precision that no propaganda could obscure. During the Pacific War, American forces destroyed over 23,000 Japanese aircraft in combat operations, while losing fewer than 9,000 American fighters. The Hellcat alone accounted for over 5,400 confirmed Japanese aircraft destroyed. achieving a cumulative kill ratio of 19-1 that validated every technical advantage Genda had documented through systematic evaluation. Japanese pilot casualties exceeded 70% across all aviation branches, creating experience deficits that made effective training programs impossible during the war's final years. American pilot survival rates remained above 60%, despite operating in combat zones throughout the Pacific Theater, enabling accumulated experience that provided tactical advantages beyond mere equipment superiority. The truth had always been available in technical specifications, performance measurements, and systematic flight testing. But institutional bias had prevented recognition of that truth until combat results made denial mathematically impossible. Japanese military culture's emphasis on spiritual strength over material analysis had created strategic blindness that prevented effective response to American technical advantages until far too late to influence the war's outcome. Genda's legacy lay not in official recognition, which would come decades later through historical analysis, but in establishing the principle that military effectiveness depended on accurate technical assessment rather than ideological assumptions. The systematic evaluation methodology he had applied to the captured Hellcat represented scientific rigor that Japanese institutions had rejected in favor of propaganda and wishful thinking. The 650 caliber machine guns, firing 4,800 rounds per minute, had represented more than impressive armament specifications. They symbolized American industrial philosophy that viewed ammunition weight as irrelevant compared to combat effectiveness. The Americans had simply decided that winning battles justified whatever material investment was necessary, then engineered and manufactured equipment that implemented that philosophy with systematic thoroughness. Japanese design approach had prioritized elegance and efficiency, creating beautiful aircraft optimized for theoretical performance rather than combat survival. The Zero remained aerodynamically superior to the Hellcat in specific performance parameters that proved largely irrelevant in actual combat conditions. Maneuverability advantages meant nothing when American pilots refused to engage in turning battles. Range advantages became meaningless when Japanese pilots died before accumulating experience to utilize available performance. The Hellcat's brutal functionality had defeated Japanese aesthetic elegance through systematic application of engineering principles focused on combat effectiveness rather than performance optimization. American designers had apparently asked different questions than their Japanese counterparts. Not how light can we make it, but how much protection can we provide? Not how maneuverable can we make it, but how fast can we make it dive? Not how long can it fly, but how long can it fight? The philosophical difference in design approach reflected broader strategic differences that determined the Pacific War's outcome. Japan had sought quick, decisive victories through superior equipment and training, assuming that qualitative advantages would overcome quantitative disparities. America had pursued systematic industrial mobilization, assuming that superior resources properly applied would eventually overwhelm any tactical or technical advantages Japan might temporarily possess. The captured Hellcat had proven American assumptions correct, and Japanese assumptions fatally flawed. Technical excellence without industrial capacity created temporary advantages that disappeared once American production reached full mobilization. Pilot quality without aircraft survivability created experience deficits that made training programs progressively less effective, as veteran instructors died faster than they could train replacements. Genda's final observation in his October 1945 report captured the essential lesson with brutal clarity. Japanese aviation had spent the entire war optimizing for the wrong variables. They had created the world's most maneuverable fighter while Americans created the world's most survivable fighter. They had trained the world's most skilled pilots, while Americans created systems that made average pilots effective. They had emphasized individual excellence while Americans emphasized systematic advantages. The result had been mathematically inevitable once American industrial production reached full capacity. No amount of Japanese pilot skill could overcome protective systems that allowed American pilots to survive and learn. No degree of zero maneuverability could defeat tactics that refused to engage on terms where that maneuverability provided advantages. No level of Japanese dedication could compensate for industrial capacity differences that made American losses replaceable, while Japanese losses remained permanent. The institutional failure to acknowledge these realities until mathematical evidence made denial impossible had transformed a difficult war into an unwinnable catastrophe. The same institutional biases that prevented accepting Genda's technical assessments in April 1944 had prevented strategic adaptations that might have reduced Japanese casualties, even if they could not prevent ultimate defeat. The captured Hellcat currently rests in Japan's Aerospace Museum, officially designated as evidence of American industrial dominance that Japanese planners had failed to adequately counter. Its 650 caliber machine guns remain mounted in the wings, silent testimony to firepower advantages that had destroyed Japanese air power through systematic application of superior resources and engineering. The aircraft's protective armor and self-sealing fuel tanks demonstrate the philosophical differences in design approach that made American fighters survivable, while Japanese fighters remained beautiful but fragile. Genda's technical report, declassified in the 1970s, provided historians with detailed documentation of Japanese understanding of their own technical disadvantages. The systematic evaluation methodology, careful measurements, and accurate predictions demonstrated that Japanese engineers and test pilots possessed the technical competence to identify American advantages. What they lacked was an institutional structure willing to accept uncomfortable truths and modify strategy accordingly. The 4,800 rounds per minute fire, 2 rate remains the most commonly cited specification when historians discuss Hellcat advantages, representing in a single number the overwhelming firepower advantage that made close-range combat suicidal for Japanese pilots, flying unprotected aircraft with limited ammunition. The specification symbolized American industrial philosophy that viewed material abundance as the path to military effectiveness. Japanese engineers had known the technical details, had documented the performance advantages, and had predicted the combat outcomes with remarkable accuracy. But institutional momentum, ideological commitment, and strategic inflexibility had prevented effective responses that might have reduced the catastrophic losses that characterized Japanese aviation's final years. The knowledge had been available. The willingness to act on that knowledge had not. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget subscribe.